Okay, we're going to talk about a couple things. We're going to cover midpoints a little later, but first I wanted to talk about shorthand for marking things that are congruent. So if you can figure out that things are the same measurement, or if you're told that things are the same measurement, then we want a quick way to mark our pictures to show that, so that we don't have to keep looking back at the actual written statements. We can just look at our picture and know which pieces are the same. So if we either prove or discover, or if it's told to us that AB, the segment, is congruent to BC, then we can mark that on our picture. All we need to do is mark those segments with the same marking. The easiest one is just put a little slash on there. Okay, now when I look at my picture, I see that those pieces have the same marking, and that lets me know that they are the same length, which is the same as being congruent. If I was told that AB is congruent to CD, okay, I would look, and AB has a marking on it already. So I want to make sure that CD gets that same marking. It would get the same one. And now I can look and see that all three of these pieces are the same. If we get into a place where we've got more than one measurement that we're looking at, okay, so here it says, it says that PQ is congruent to QR. Well, I'm going to mark those as congruent, give them the same marking. It also says that RS is congruent to ST. Now, RS is not the same as PQ or QR. So I'm not going to give it the same marking that those have. I have to come up with a new symbol or new marking. Okay, so when we have a few things, you can just give them 2 slashes instead. And now I can quickly look and see that, these two are the same, and these two are the same. That doesn't mean they're all the same, it just means the ones with the same markings have the same length. When we eventually get into, more complicated pictures, we have a lot of different congruencies going on. It might get a little confusing to start seeing, 4 slashes on different segments in conjunction with, 2 slashes here, 1 slash there, 4, 5, or whatever. So you can get creative, and maybe instead of slashes, you can put squares. Okay. Whatever you want to do, just make sure they have the same markings on them. So you could do, a square and a circle. Okay. Those segments have the same markings, so they're congruent. That's kind of our shorthand. Now we're going to talk about the midpoint. Here's your midpoint formula. There's a couple ways to think of this. If I want to reference it to another math concept, it's an average. Okay, so I've got 2 things here. I'm adding them up and dividing by 2. That's how you find the average of 2 things. So really, we're going to average our x's, average our y's. Because an average is a representation of the middle, and we're looking for the middle point or the average point. So let's use that formula. Let's skip this. Use that formula to... Actually, I'm not going to skip that. Okay. We're going to use this formula. We're going to go back a page. And we're going to try to show that B is in fact the midpoint. Okay. Let me get this out of the way. So I'm told that B is the midpoint, and I want to verify that. Okay, well, there's 2 ways I could do it. I could use the distance formula here, find out that distance. Okay, it would turn out to be 5. I could find this distance, find out that that's 5. Okay, so that would show me that, as long as these are collinear points, B would be in the middle, because it's the same distance from A. Because the same distance from A as it is from C. But I would still have to go through and find AC to make sure that these are collinear, because I need to make sure that AB plus BC equals AC, because that's my segment addition postulate. Okay, so I'd have to do all that work just to find out if B is the midpoint. I don't have to do that anymore because I have the midpoint formula. So I can just use A and C as my x1, y1, x2, y2, and then put them into my midpoint formula. Okay, so I'm going to average my x's. So I'm going to take my two x values, x1 and x2, and I'm going to add them together. -4 plus 2, and then divide by 2. I'll do the same thing with my y's. Take my two y values, -3, add it to 5, and divide by 2. Okay, so I'm averaging my x's. Here I'll get -2 over 2, which reduces to -1. Here I'll get 2 over 2, which reduces to 1. This is my midpoint, and there I've confirmed it. Okay, so it's a little easier than using a segment addition postulate in your distance formulas. Another use for this is if they give you a midpoint. Okay, so they're telling me this is my midpoint of Q and some T. I don't know what T is. I'm trying to figure that out. There's a couple ways to do this. First way is to use our midpoint formula again. Okay, if we look at it, this T would really be my x2, y2, so I don't know what those are. But I can fill in what I do know from the formula. I know that if I take x2, which is unknown, add it to my x1 from over here, and divide by 2, that should equal the x-coordinate for my midpoint, which is 5. Okay, if I take my y1 from over here, add it to my y2 that I don't know, y1 being -3, divide by 2, that should equal the y-coordinate from my midpoint, which is 1. Now I've got two equations I can solve, which will help me find what the missing endpoint is. Okay, to solve this, I need to get rid of this 2 on the bottom first. So I'm going to multiply both sides of the equation by 2. Okay, same thing over here. Okay, and that's going to cancel the 2 here. So then I'm going to have x2 plus 2 equals 10. y2 minus 3 equals 2. So then I would subtract the 2. So that this would be 8. Add the 3, so that this would be 5. Okay, that's the first way to do it. The other way is we can look at movement. Okay, when we look at movement, it's really convenient to have them set up like they are over here. Okay, one on top of the other. So we start thinking about midpoint. Okay, midpoint is exactly in the middle. So if I look at my movement, okay, if I'm starting at an endpoint, there's a certain amount of movement that I'm making to get to my midpoint. Okay, so in this case, I'm going from 2 to 5. That means I'm going over 3 places. Okay, so my movement to get from my endpoint to my midpoint, I'm going over 3, and then I'm going from -3 up to 1, which is a positive increase of 4. So that means to get halfway, I went over 3 and up 4. So if I want to go the other half of the way, I do the exact same thing. I go over 3 more and up 4 more. So that means that from my midpoint, I need to go over 3 again. So I need to add 3 more onto this, which puts me at 8. I need to go up 4 more, which puts me at 5, and that's the same answer that we had from using the equation. So those are the two ways to do that. So I'll quickly run through a couple more examples. Okay, so if I want to find the midpoint here, use the midpoint formula. When you're finding the midpoint, you use the formula. When you're finding the endpoint, if you liked, this way, if you like this way, then you're using the formula again. Just remember that you're going to have an unknown inside the formula. midpoint, I'm going to average my x values. So I'm going to add these two together. I get -9, and I'm going to divide it by 2. That's my x coordinate of my midpoint. I'm going to add these together. That'll give me 0. I would divide by 2, so that's 0. There's my midpoint. Okay, let's say I want to find another endpoint. So this is the counting one. I'm going to look at my movement. To get from 6 to 1, I had to go subtract 5. If I subtract 5 more, that's going to put me at -4. To get from 3 to -4, I subtracted 7. If I subtract 7 more, I'm going to be at -11. That's my other endpoint. So in this case, since I'm looking for the other endpoint of KD, this would be point D. Okay, and there's some problems for you to work on to practice with the midpoint, and there's some extra ones on the website.